Hey everybody, so the last thing that I want to talk about in this module on tables is actually cases in which you might not want to use a table to display your data. So the reason I'm saying this or talking about this is because frequently you'll see people display data in a table where you're thinking, wow, a different visualization would clearly be appropriate or make it more apparent what the author is trying to convey. So if you have like a time trend for one case or a small number of cases, that's clearly a case where you want to have a line chart rather than displaying that data in a table. Or if you want to show the relationship between two variables for a large number of cases, like we've said in earlier modules, that's a case where you want to have a scatter plot. Or if you have a small number of country cases or regions and you're trying to show the levels of a variable and how they differ across those cases, that's a case where you want to have a column chart, right? Another case that comes up frequently is if you want to show an estimate of something or a coefficient and a margin of error or a confidence interval. Sometimes these data will be displayed in tables, but it's hard to really visualize what's going on, and it would clearly be better if there was some sort of interval plot or coefficient plot. So in this module, we're going to talk about interval plots for an estimate of a statistic, and in the next module, we're going to talk about coefficient plots related to regression analysis. So the example we're going to draw on here is, again, we're going to take data from the American Community Survey, but this time we're going to be looking at data on the median income for counties, okay? And we're going to plot the estimate of the median income for each county in a state, and then we're going to take the margin of error and produce an interval plot using the estimate and the margin of error for each county, okay? So let's go ahead and get started. So we can just write some text here. Let's extract the median income. First thing we have to do is to wrangle some data. So let's extract the median income for counties, and we're going to do the state of Massachusetts because it has a reasonable number of counties to work with. So we'll go ahead and start a code chunk, and we can label this, let's label it county data. All right, and yep, and I'm going to go ahead and load the janitor package because I'm going to use it to clean up the variable names later. And we're going to store these data in an object called Massachusetts, basically Massachusetts median income, or for short mass underscore med underscore inc, and then we're going to use our get ACS function. And remember, to use this function you have to have the tidy census package loaded, and you have to have your census API key loaded as well. I covered that in an earlier module and also give some instructions on the course website on how to do that. So our geography this time is not going to be states. This time we're going to pull data at the county level, like I mentioned. So geography equals county. And then our variables, I've already looked this up, so we won't spend time searching for the variable. We're going to pull the median income. Let's call it median income equals B 06011 underscore 001. All right, B06011 underscore 001. And then the state that we're going to be pulling the counties for, we have to add that as an argument to specify which state we want is Massachusetts or MA. And then the year, again, is going to be 2021. All right, so that is our get ACS call. So let's go ahead and run that and see what our data look like so far. And where did it put that? Mass, here it is. And so what we can see is we have a GeoID, a name for the county, the name of the variable, the estimate, and the margin of error. This margin of error is for a 90% confidence interval. So we are going to build that confidence interval by adding this margin of error to the estimate for the upper threshold of the confidence interval and subtracting it from the estimate to define the lower boundary of the interval. All right, so let's go ahead and do that as our next step. So here we will do a mutate, and we will produce the lower 90th boundary of the interval, and that is going to be estimate minus the margin of error. And then we're going to produce the upper boundary of the interval by adding the margin of error to the estimate. All right. And so let's go ahead and run that. And see, now we have the lower boundary and the upper boundary of this interval. All right, now let's just clean it up a little bit. We'll run the janitor clean names. And we will do a string replace all to just have the county names here. So we're going to get rid of the state name in the name column there. So we're going to do name equals string replace all, and we're going to do we're going to take name, the name field, which has now been made lowercase after we apply the clean names function, and then county underscore Massachusetts, and we want to just get rid of this. So we're going to put, so the first part of this function is the variable that we want to change. This is the text that we want to change, and this is what we want to change it. The third parameter here is what we want to replace this with, right? So we're going to replace this with this, which is nothing, right? Okay, so once we've done that, we can select the variables that we want to include in the final data frame here. So we want name, estimate, lower 90, upper 90. Okay, so let's go ahead and run that. Let's have a look up here. And there we go. We have the name of the county, the estimate of the median income for the county, the lower boundary of the 90% confidence interval, and the upper boundary of the 90% confidence interval for this estimate. All right, so now we have our data. So what should we do with it? So the first thing I want to show you is that if we do this with the table, it doesn't convey the information in a useful or clear way. So a table is not that great for displaying these confidence intervals. All right, and so let's just go ahead and add a code chunk, and we'll label this bad table. All right, I don't think we've used that before. And then from here, let's just run a cable command. We'll use the cable function from the cable extra package to just display these data in a table. So there you have it. That's what these data look like in a table. And it's kind of hard to interpret, isn't it? Because first of all, this estimate should go between the lower 90 and the upper 90 boundaries of the of the intervals, so you've got to do some mental gymnastics to put it in there. And then you've got to think about, really hard about how these numbers compare across the counties. It's not obvious, right? So again, you've got to like almost plot this in your mind. It would be much easier if we had a plot that did that work for us. So that's what we're going to do next. So let me just close this here. So now let's make an interval plot. All right, add a code chunk. And we're going to use ggplot2 to do this, so let's load that. Okay, so we're going to take our data, and we're going to pipe them into ggplot. And here, for our aesthetics call, our x-axis is going to be the estimate of median income. And on the y-axis, we're going to have the names of the counties, and we want them to be ordered in terms of the value of the estimate, right? So that it's easy to compare the levels of median income across the counties. So we're going to reorder the name, the county name. We're going to reorder the counties in the order in which they show on the y-axis according to the value of the estimate, right? So counties with the highest median income are going to appear at the top of the plot, and those with the lowest will appear towards the bottom of the plot. Okay, so the next thing we want to do is to call geom error bar. And what we're going to do with this is we're going to create our confidence interval, right? And geom error bar takes two arguments, an x-min and an x-max, that define the lower and upper limits of the confidence interval. So our x-min and our x-max are going to be lower 90 and upper 90. Okay, so let's go ahead and put that in. So x-min equals lower 90, x-max equals upper 90. Okay, and then the next thing that we want to do is we want to have that nice point, that dot in the middle of the confidence interval that defines our point estimate for the median income. So for that, we'll call geom point, and we'll make it, let's make it red. And let's specify size equals 2 to give it some visibility. All right, and then from there, we're just going to add some labels. We can add a title. We can take the y-axis label out. I think that would be appropriate because we don't need the y-axis label to have the names of the counties that also say name. We don't need a label for the y-axis, so let's leave that blank. And then for the x-axis label, we can say median income, and then we can have a caption or a source note. So we can say ACS estimate bars represent 90% confidence intervals. Okay. Okay. And then let's give it a theme. I always like theme minimal. All right, and let's go ahead and run that and see what it looks like. And there we go. There are point estimates for median income for the various counties. And we can see that some of these are quite wide, probably because the sample is small. So that's important information, right? That we don't have a precise estimate for some of these counties. And we can see the variation across the counties much more clearly, and we can see where those differences are probably statistically significant. So for example, Essex and Suffolk counties are pretty similar, whereas Norfolk and Hampshire are clearly very different. Or even Norfolk and Plymouth are very different in terms of the median income. All right, so that's how you make an interval plot. And like I said, for this use case, and also oftentimes when you're doing regression analysis, not always, sometimes a table is more appropriate, but oftentimes if you have just one set of estimates, it makes sense to have a confidence interval, and that's something that we're going to talk about in the next module. I'll see you there.